arithmetic and geometric sequences, we need to be able to test for them so that we know which one we're dealing with so we can apply the relevant formula. With the arithmetic one, we have this formula, and I'm recommending you put the D in brackets. And with geometric, we have that formula. And a reminder then that you have to multiply the n-1 into the r before you can multiply the a in. And sometimes these ones end up rather clumsy looking, and you just have to leave them like that because of exponential law. Here you're going to test for a constant difference, and you're then going to sub in your first term and your constant difference to finding the formula. With this one here, you're going to look for a constant ratio, and once you've got that, you can apply that into the formulas. So when we're finding the formulas, it is simply a matter of substituting in the things that we've got, and that is when you're already given the sequence. With this one, it's relatively straightforward, and you've probably been doing those since grade 9, but with the geometric sequence, which is new, be careful at the end when you're subbing in. You can't do anything with the n-1. The answer must have an n in it, and even though that looks quite clumsy, at this stage it's perfectly acceptable to leave it like that. The next kind of simple question that you can be asked is to find a value. And just like you've done before with the linear and quadratic, you're just going to sub in the number that they give you. When they give you the position, you're going to sub it in and find out the actual value. Here it works the same way. This one had to be done on the calculator. We had to round off to 2 decimal places. And that concept is a little bit unusual until now, so just be mindful of the fact that that can happen. When we're finding a position, it's because they give you the value. The question can be asked quite strangely, like here, find the number of terms of the last term, and they give it to you. But at the end of the day, you're doing the same thing. They're giving you the value, and you're finding the position. So we must remember at the end that that's what we're doing, that we are given the value, and we're finding the position. When it comes to the geometric ones, we're going to have to solve exponential equations. So that is an old skill we're going to have to bring back. They ask which term is equal to a number, and we've got to solve this equation. A reminder that when you have 4 times 3 to the n-1, you have to get rid of the 4 first before you go and put things in prime factors. And when you do, you can use the calculator using the factor button on the shift function. This is a question where there's variables in the terms, and they're asking you to find the variable and also the possible sequences. With the arithmetic one, what we did is we know that because it's arithmetic, you can equate the differences. We know that there's a constant difference, so we know that T3 minus T2 equals T2 minus T1. And what we did here is we merely subbed in those terms as they are, being careful to put brackets when we're subtracting, and we got out a value for k. When we got the value for k, we then subbed it into each of these terms and got out a sequence. But the geometric one was a little bit more complicated. Here we had to equate the ratios of the different terms. So we put T3 over T2, and that's been substituted there. That equals T2 over T1. And then we're using the cross-multiply trick for equations that have fractions in them. Cross-multiplying then, I end up with binomials that I need to multiply with each other. So I'm using the FOIL method, getting out my answers, tidying them up to end up with a quadratic equation, factorizing and getting out 2 answers for k, because this one happened to be quadratic. The sequence is not quadratic, but finding k led me to a quadratic equation. When I get the 2 different answers for k, I get k as 3 and k as -2, reminding myself that was the original sequence. Again, all I'm doing is substituting into that sequence for my different k values, and this is my possible sequence if k is 3, and this is the possible sequence if k is -2.